At the moment, strong multimodality, so basically merging the visual and the auditory, the behavior world and so on with the language models is one of the next frontiers. Another one is continuous time. So this thing should be able to be coupled to the world in real time, and it should be able to learn in real time in a similar way as we can do this, hopefully better and faster. And this multimodality, for instance, can mean that we take an image-guided diffusion model and we couple it to connect it to a camera, and then we use the camera input to guide the image to a local minimum where it's able to track the camera image. In that case, the activation of that model is a semantic representation of the contents of the scene, which can be correlated to a language model. So this thing can reason about the contents of the scene. And I think this is going to be a very exciting new frontier when we use these image models, not just for generation, but for tracking visual data and use them for perception. There are other ways of integrating the perception, and I'm very interested to see real-time perception combined with language models. Another thing is these models at the moment are trained on static images. You give them, in the case of DALI, 800 million pictures and the, captions to them. And it's amazing that learning works at all. But for us, the world is learnable because it has information preservation between adjacent frames, which means it changes continuously. And because these rules of these, by which the world changes are relatively simple, right? Mostly it's stuff moving in space with limited deformation. And when there is more interesting deformation, it's because there's an agent behind that we can also model, right? The world becomes learnable for us. But training on video is completely new for these models. It's something that is still in the beginning, and we're not able to generate large movies with the existing generative models yet. But even though for your organism, it is much, much easier to learn. There's, of course, a technical problem. Easier to learn still means that the first 6 months, the baby has to learn basics. And learning deep structure of the world takes decades. And if you feed in sequential training data from the real world into a model, it's only going to be a small factor faster than the way in which we learn. And if you want to tune the model and try many, many variants, and each time you need to wait for 12 years before you do the next experiment, that is not very productive, right? We are fine with our models costing $10 million, much more than waiting for 10 years if we get the result for these $10 million within a month. There is no proven limit to the general capabilities of these models. So when somebody like François Chollet or Gary Marcus says that they cannot do X, they don't have a proof for that, which means they're not wrong. It's not clear that they're wrong, but the claim is weak at this point. We don't know. I think as scientists, we have to remain agnostic. So as long as we don't know the limits of that, the scaling hypothesis is still on. And the scaling hypothesis is the one that Sam Altman and others believe in, which say the present set of algorithms is probably good enough to get to a good enough AGI, probably not a very elegant one, but something that is good enough to build better AGI. And that's a very interesting hypothesis. And at the moment, they're still winning, right? And so it could be that it's plateauing soon, but we don't know yet.